Here is the second part of the review guide. Now we get to use our calculator, so this is where you want to use the TI-83 calculator. So let's go ahead and look at the first problem here. The formula for the distance at a constant speed is calculated by, so distance equals 1/5 t plus 20, where t is the time in seconds, d is the distance traveled in meters. So distance, and I like to write down the original thing, equals 1/5 times time plus 20. Solve this equation for t. So we just want to get this t right here alone. So just like we solve equations, we would undo any additions or subtractions first. So let's subtract the 20 from both sides. So on the left, you're going to get d minus that 20. And that equals 1/5 t. And now we just have one more step to get the t time by itself. It's 1/5 t, so I'm going to multiply the right side by 5. 5 times 1/5 is just 1. And I'll multiply the left side by 5 as well. I end up with 5d minus 100 is equal to t. So t equals 5d minus 100. And we can see 5d minus 100 right there. I don't see anything else that has that, but let's double check it by answering part 2 here. So there's what t is. Note when I distributed that 5 there, that's where the 5d and the negative 100 came from. And then lastly, if I want to figure out how long does it take to travel a distance of 100 meters, well, t equals 5, distance is 100, minus 100, so that's 500 minus 100, which is 400. That guy right there, 400 seconds. Number 17 is just a solve this equation problem. For this one, well, I'll go ahead and just distribute, and we'll attack it like you would. So that'd be 0.5x. 0.5 times 1 is just 0.5. Distribute negative 5, you get negative 15x. Distribute negative 5 times negative 2, you get plus 10, equals 8.3. Now remember, you can get out a calculator for any of these problems at this point. So here's a 0.5x minus 15x. Now they're both on the same side of the equal sign, so you just add those two together. 0.5 minus 15, so that's negative 14.5x's. Then I've got minus 0.5 plus 10, so that's a positive 9.5, equals 8.3. And now we're at a two-step solve problem. So we'll erase a little bit here, give ourselves some space. I'm at negative 14.5x plus 9.5 equals 8.3. Subtract the 9.5. Minus 9.5. What's that? Give me an 8, I think. Negative 0.8. Negative 0.8. And so x is equal to, I divide by my 14.5, negative 0.8 over 14.5. You get the point. It solves to whatever it does. Now I'm going to simplify this. I'll take the top times 10, take the bottom times 10. And I think that's it. So it looks to me like x equals negative 8 over 145. Not super confident in that answer, but we'll go with it for right now. Number 18. U-Move Rentals charges a flat fee of $200 for a rental truck. So U-Move charges a $200 flat fee. For each mile driven, they charge $1.20 plus $1.20 per mile. If you only have $275, how far can you drive the truck? Okay, so the cost to drive the truck is $200 plus 1.20 times, it says here, let m equal number of miles times m equals, doesn't equal to, yeah, it could equal up to $275. So we'll go $275. So right here is the cost to rent the truck. Here's $200 they charge you right away. Then $1.20 for every mile. So if it's 1 mile you drove it, they charge another $1.20, giving you a total of $201.20. And you can spend up to $275. So that's our equation. The amount it costs us based on miles can only equal out to 275. So now we just solve it. Subtract the 200. 1.20 m equals 75. And so m is equal to 75 divided by 1.20. So I get out my calculator, and 75 divided by 1.20 equals, I can drive about 62.5 miles. And that certainly, by writing the equation and then solving it, justifies it mathematically. Question number 19. Which is the equation of the line that passes through the point 4, 5 and is parallel to this line? Well, there's some key information there. So I need the equation of the line that goes through the point 4, 5. Should have written down the point 4, 5. And since it's parallel to this line's in slope-intercept form, y equals mx plus b. So the slope of that line is a half. So the slope of my line has to be the half. So at this point, I can just go ahead and start to rule out some of these equations. Like this one's got a slope of 2, and this one's got a slope of 2. So you're really down to just these B or C as your possibilities. To formally find this, what you're going to do is you pull out the point-slope equation. Our point, if you recall, is the point they give us, x1, y1. So we go y minus, we put in our y1, equals m, and we know m now, it's a half, times x minus our x1, and x1 in this case is 4. So there's our equation. It's just not in slope-intercept form. So we distribute the half. Y minus 5 equals half x. And half times 4, half of a 4 is 2. So we just finish here. I'll add 5. And I get 3. So a half x plus 3 must be that one right there. Now, I'm not even sure I'd go to all that work. As soon as I had it narrowed down to those two, I would say, well, if x is 4, and I'd plug a 4 in here, a half times 4 is 2, and 2 plus 3 is 5. So when x is 4, y is 5, I would know exactly that B is my answer. Number 20. James biked 5 miles in 20 minutes and 6 miles in 30 minutes. Write a linear equation to model this distance. So this is essentially find the equation of a line, and in this case, they've given us 2 points. We want it to model distance in t. So we'll make t our x, and we'll make distance our y. And so they've given us 2 ordered pairs. They've given us 20 minutes for 5 miles, and they've given us 30 minutes for 6 miles. And so we can find a slope for these 2 points. Slope in this case would be 6 minus 5 over 30 minus 20, or 1 over 10, or 1/10, 0.1. And then we can write the full equation just using that point-slope form, y minus, and you can use either point. I'm going to use the 5 and the 20. So y minus 5 equals my slope times x minus 20. And then we'll distribute that. That's 0.1x minus 2. And if I add 5 to both sides, I get a 3 over there. And so you can see it's this guy right here. And hey, how far can you go in 75 minutes? Now we could use this equation here. Our time is 75, so we could just plug in a 75 like so and add 3. So 7.5 plus 3, or 10.5. miles. You can see it fits. Next one, number 20. We switch gears now. We got an absolute value equation, and it's just solve it. So what we want to do is isolate the absolute value. So we've subtracted 10 from both sides. Now, this is kind of an interesting problem. Look what happens here. The absolute value equals -8. Think about what you're trying to do. You're trying to solve this for x. Well, it doesn't matter what x is. When you take the absolute value of it, you get a +8. So there's nothing that works for this one. We'll just put no real solutions. Let's make sure I get to the bottom. Yep. On the next set of problems, this is 22, 21, 22 right here. Let's see here, another absolute value equation. So we're going to get that absolute value by itself. I'm going to add 4 to both sides, and I get 12 over there. Okay, that's just doing +4 +4. We'll divide both sides by 2, giving us a 6. And now we can write 2 equations. Now, a real quick way to write this one for less thans like this is you can make it one big inequality by writing the following. Remember, we say you have to flip this and change the sign. Well, this does it all in one step. My distance has to be less than 6 units, so x plus 3 has to be less than 6. Or, at the same time, the x has to be bigger than -6. Remember, we're trying to get our distance away from 0 to be less than 6 units. And so that's what we've written here. And if you do it this way, then it's really simple to solve. You can do your -3, and finally -9, less than or equal to x, less than or equal to 3. And so let's see if we got that answer up here. Yeah, there he is. And so we're done. Let's see here. The next one. Another absolute value equation. Now, if you notice, we do these things each time the same way. We get the absolute value alone. In this case, I divide by 3. This is another interesting problem because this time it's saying, hey, what is the absolute value of something? So imagine you put in any number you want for x. Maybe you put in 10. 10 minus 5 is 5, and you take the absolute value. And the question is that answer then greater than -4? And it is. So then you'd know 10 is one of those solutions that works. But because we always have to be greater than a negative, think about it, no matter what x you put in, when you do the absolute value, it's always going to be bigger than -4. In fact, even if x was 5 and this came out to 0, you'd get 0, and 0 is greater than -4. So it's always going to work. So we're going to choose A here. All real numbers. We don't have to do any math. 24, this is an old school one here. Find the f of -5, and here's the function. So here's our work. We've done a lot of these. F of -5 equals, in every place in that equation, it says 4, then it says x squared, but we put in a -5 and square it. Then it says 3 times x, so 3 times -5. It says subtract 2. Now remember, we just work on the right-hand side here. We never touch the left-hand side. So I'm going to square the -5 first. -5 times -5 is 25. And then I'll do this, I'll just do all my multiplications next. Now I'm going to multiply from left to right. So that's 100. That's -15. That's -2. And that's going to be 85 minus 2. And I get an 83. So the f of -5 equals 83. Next problem here. Number 25, find the slope between these 2 points. Okay, we should know the slope equation. Slope is change in y, rise over run. Change in y over change in x. Remember, it doesn't matter which ones you call x1 and y1 and x2 and y2. Just make sure the 2's are with the 2's and the 1's with the 1's. So y2 is 12 minus y1, which is -8. So be careful, we're getting double negatives there. Over x2, which is 3, minus x1, which is 3. Holy cow. On top, we get a 20. On the bottom, we get 0. Now, don't forget, this is something you can type into your calculator, and your calculator will give you error. Okay, that's because this is not possible. This is undefined. That's D. And if we'd noticed here, our x's were exactly the same. They were both 3. And so this line would have to be a vertical line, and vertical lines have a slope that is undefined. 26, I love this question. It pops up, and it's so simple. State the solution to the system of the equations graph. So we've got 2 equations. Here's one of them. There's all his solutions. Here's all the solutions to the purple equation. And so where do the solutions to the system lie? Well, right where they cross each other. That's where they share it. So that is at, here's our origin. So this is 5, 6. It's over 6. 1, 2, 3, up 3. So we want to choose 6, 3 right there. 27, not quite as easy as the previous one. Solve this system using any method. So our methods are graphing. And then we have substitution. And we also have elimination. And I think elimination is the most common to use. When they're lined up like this, notice how the x's are lined up, y's are lined up, equals, and then constant. So that's generally how we like it for an elimination type problem. Remember what we're trying to do. Add these 2 equations together so that such that either the x's or the y's disappear because they add up to 0. So let's say I want to get rid of my y's here. I would try to make this the common multiple of 2 and 3. And the common multiples, if you think about multiples of 2, goes like this, and multiples of 3. So 6 is the least common multiple. And so what you want to do is make one of those a positive 6 and the other one a negative 6. So I'll take this equation. Let me erase these 3 methods so we have plenty of space. Let's just write it just a little bit bigger here. So let's take this top equation times a 3 and watch what happens. The whole equation gets tripled, so we get 24x minus 6y equals 36. And see, now I've got this nice negative 6 here. And so I'm going to do something to this 3y to make it into a positive 6y so that they cancel each other out. So I'm going to take this one times a negative 2. And again, I distribute that to everybody. So negative 4x, negative 6. Ooh, I don't have to use a negative 2. My apologies. That should be a positive 2. Got to get the opposite sign there. So 2 times 2 is just a 4x. 2 times 3 is a positive 6y already. And 2 times 3 is 6. So now we can add them up and we'll see what we get. We got 28x equals 42. So x is 42 over 28, or both divisible by 7, giving us 6 fourths. Oops. There we go, 6 fourths. So there, gosh, we can keep on going. 3 halves, I guess 1.5. Now that we know what x is, and I'm going to use it as 1.5, I think that'll be easier to substitute in. We have to take that and substitute it into one of our equations. I'm going to substitute it into the bottom one, so it's 2 times x, but x we now know is 1.5. Then plus 3y equals 3. So 2 times 1.5 is 3. That's 3y equals 3. It looks like, subtract 3 from both sides, I get 0 there. So 3y equals 0. And when I divide by 3, 0 divided by 3 is 0. So these 2 lines must cross at 1.5, comma 0 on the x-axis. Number, see, that was 27, yep. So we are at number 28. Is 8, 5 a solution to this system? So we just have to test it here. Okay, so it says to show our work. So here's how we'd show our work. This is our x, this is our y, so we're going to go 2 times 8 minus 3 times 5. And we'll see if it works here. That's 16 minus 15. 16 minus 15, which is 1. Yep, that checks. Let's check it in the other one. 5 times 8 plus 2 times... Oh. I think Mr. Todd has a typo in there. That's supposed to be a y right there. Plus 2 times 5 is equal to 40 plus 10, or 50. So it doesn't look like it works for that one after I fix my typos. That's 40 plus 20. Yeah. So no, not a solution. And there's the work that shows it. 29, solve the system of equations using any method. This is just a, well, see how they aren't lined up this time? And so in this case, we can do substitution. Since this one's already solved for y, we can just substitute it right in for this y in the second equation. So here's my second equation, negative x plus, but now I'm putting in what y is equal to. Now y is equal to negative x minus 5. And then that equals 9. So it's just this equation here, but I've replaced what y is. Now let's see if we can clean this up. Negative 1x plus another negative 1x. That's negative 2x's. Then we'll move this 5 over to the other side, giving us 14. I apologize. We'll divide by negative 2, and I get x is negative 7. The nice thing about substitution is right up here we have this equation here. It says what y is, and it says y is equal to negative of x. Now, careful here. X is a negative 7, so it's the negative of negative 7 minus 5. Double negatives gives us 7 minus 5, which is just 2. So these two share a solution at negative 7, 2. An ordered pair because that's where they intersect. Problem number 30. Car company A charges $50 flat fees. That's $50. And $3.25 a day plus $3.25 a day. Car company B charges $30, but they charge $4 per day. So $4 times D. So if D is 1, they get 1 times 4. If D is 2 days, 2 times 4, etc. Write an equation to represent the cost for renting a car at each agency. Well, that's what this is. These both calculate the cost for D days. So these are our equations. They charge $50 plus 3.25 times each day. And you just add those to get your total cost. Same thing with the $30 flat fee plus $4 a day. So let's see if we got any of those equations. There's a 3.25D plus 50, yeah, equals C. 4.00D plus 30 equals C. So it looks like it's that one right there. In fact, it's the only one that really works. In this case, now we could solve it. To solve it, since these two are both C already, we can just set them equal to each other. Like so. So there's the first equation, and that has to equal the second one. That's what we're asking. When are the costs equal to each other? And so we get this nice little equation. I'm going to subtract the 3.25 here from both sides. So I got my D's on the right, and that gives me 0.75D. And then if you move this 30 over to here, you'd subtract as that's 20. So D is going to be equal to, divide by 0.75. 20 divided by 0.75. 20 divided by 0.75 on my calculator, it says 26.6 days. Round it to the nearest whole days, so 27 days. So there it is, but once again, once we found that equation, we were pretty much set. Next one, solve this system of equations. These take an incredibly long time, everybody. It is a multiple choice question, so I think I would go with testing these things. Okay, so I would take 1, -2, and 0. I would substitute it in to see if it makes the first equation true. If it does, test it in the second equation. If it makes that one true, try it in the third. If it makes it true for all of them, you found the right answer. So let's test it in the first one. It'd be 4, and x is positive 1 there, minus 2 times the y, and y is -2, minus 3 times z, and z is 0. The question is, does that equal 8? So this is a 4, and this is -2 times -2 is 4. So this is 4 plus a 4. That's 8. So this does check for this first equation. Let's try the second equation. 5 times 1 plus 3 times y is -2 minus 4 times 0. Does that equal 4? Okay, so I'm just taking this x, y, and z and putting them right in there. It's 5 minus 6 minus 0. 5 minus 6 is -1. No, it doesn't equal, so it does not work. So we can now rule out answer A. Let's go to answer B. 3, -1, and 2. So here's the first equation. It would become 4 times 3, -2 times -1, minus 3 times 2. See here, this is 12 plus 2 minus 6. 14 minus 6 equals 8. Yep, it checks in the first one. Let's check it in the next one. We got 5 times 3 plus 3 times -1 minus 4 minus 4 times z is 2. Does this equal 4? 15 minus 3 minus 8. That's 15 minus 11. 15 minus 11 is 4, so it checks in the second one. So if it checks in the third one, we know we have that one spot where all three of these planes intersect each other. So here comes the third check. 3, we're still saying x is 3, minus 4 times y is -1, -1, minus 5 times z, which is 2. Does it give me this? 12. 18 plus 4 minus 10. 18 plus 4 is 22, minus 10 is 12. Yep, it checks. You are guaranteed it is 3, -1, and 2. Problem 32, simplify the expression. So this is just the distribution, so look what you get. See, 3 times -4 is -12. 3 times 2y is 6i. 2i times -4 is -8i. And 2i times 2i is plus 4i squared. -12, let's see here, minus 2i's plus 4i squared. Now, something we will learn before this is I squared is equal to -1. So that gives us -12 minus 2i minus 4. -12, -4, that's -16 minus 2i's. Right there. Problem 33. Write the vertex form. So they're kind of crowded here. There's question answers A, B, C, and D. So here's our vertex. Let's see here. That is at 5 on the x and 2. So if we write our equation is y equals a times x minus h squared plus k. X minus our h, remember this is h, so it's 5. And k is a 2, so it's x minus 5 plus 2. It's got to be this guy right here. And that's it. Let's see here, problem 34. Solve this guy. They do not give us any directions for solving this guy, so we're going to graph him. So I'm going to pull out my graphing calculator here. So on 34 here, it says to solve this equation. So the first thing I notice is it's quadratic. Okay, when they say solve it, they're looking for the x-intercepts. And so we haven't practiced factoring when this thing is a 5 out here. All of ours just had an x squared. And so what we are doing right now is just graph the thing. And so I've graphed it here, and you can see I found two solutions. And so my answers are 0.4, or 2/5, and 4 for the other value. Remember, those are just intercepts, and our calculator finds them. You can do a trace, and if you get 4/10 and you want that as a decimal, it's just 4/10 or 2/5. Okay, so that's this point right here, and then the 4 zeros, your other ordered pair. But it's just to say the y, or the x-intercepts rather, are 0.4 and 4. Number 35, we could do the same thing with, but notice how it's equal to 0. Okay, that's what we did here in 34. We looked for where does it equal 0 at. Okay, those y values are 0 there. But the other one of the ways we learned also is how to factor these when that x value was, or the coefficient was just a 1 out front. So in this case, I'm trying to get them to multiply to get a 15. So to get 15, it could be a 1 and 15 or a 3 and 5. So clearly we want the 3 and the 5. So I'll make one of them 3, one of them 5. They have to give you a positive 15 and add up to 8. Well, we'll just make them both positives. But now we can solve it. Remember, x equals negative 3. You have to set it equal to 0 to solve. And x plus 5. So what I'm doing there, let's just move this guy out of the way. After I have it factored, you take the first factor, x plus 3, set it equal to 0, and solve. And so that's one of the answers for x. Then you take the other factor, x plus 5. Set it equal to 0, x equals negative 5. There's your other solution. Let's see here. I've covered up this thing, so let's get rid of him. There we go. Last question here on this page, 36. What is the value of k in this equation here? So we got an 8x squared, 26x, and 15. Remember, we've talked about this last terms, they have to multiply to give you the last term here. So if we got to get a 15 and we got a negative 3, k must be a 5, because then we'd have negative 3 minus a 5. Negative 3 times negative 5 there would be a positive 15. So k is positive 5. That's it. Now, on the last page here, let's find the zeros of this function. Again, we could graph this guy and take a look, but let's just see if he can factor. Whenever we see that x squared like that, think factoring. So x and x, we got to get 10 here. So it's either 1 and 10 or 2 and 5. We've seen this one, I think. Remember to solve these, set the factor equal to 0. So x is negative 2 or x is negative 5. 39, this function. Again, I'd write down that function. Anytime they tell you something, write it down like that. 4.9 t squared plus 550. Tells you how high it is, y in feet of a stone after t seconds. When it's dropped from the edge of a cliff. So here's a cliff, there's a stone, we're going to drop it, and it's going to fall to the ground. Now the question is, when does it hit the ground? So when it hits the ground, its height down here would just be 0. So we're just trying to solve this equation, negative 4.9 t squared plus 550. When does it equal 0? So just put 0 in on the y value. So to solve this guy, and I'm going to flip him around, because we usually have our numbers on the left and the 0 on the right, or t squared on the left. This is just a quadratic. See that t squared? So to solve this quadratic, since there's no b term, there's no t to the first power, we're just going to use the square root method. 4.9 t squared equals negative 550. T squared equals, now I'm going to get out my calculator, and I'm just going to ask the calculator, what is 550 divided by 4.9? It tells me it's 112.24. Then I got to square root that to figure out my time. So when I square root it, it tells me about 10.6 seconds. 10.59 seconds is what it comes out to. Now this is actually plus or minus 10.59 seconds, but we want the one in the future, so we do want the positive 10.59. 39. Which are qualities of a parabola? Circle the ones that are true. The zeros and the x-intercepts are the same. That's true. The axis of symmetry always passes through the vertex. True. N is symmetric. I think that's supposed to be it is symmetric, and that's true. It has an axis of symmetry. Its domain is all real numbers. Yep, that's true. It has a maximum or a minimum. Yep, that's true. So all of those are true for a parabola. Find the vertex of the parabola modeled by this equation. There we are. That's vertex form. X minus h squared plus k. So h is 5, k is 3. Vertex 5, 3. Done. Here's one we haven't seen before. This is a complex number problem. I will tell you this. This is the complex part, or the imaginary part, the part with the I. And this is the real part. And to add complex numbers, so that's an addition, you add the imaginary parts. So 3 minus 7 or plus negative 7 is negative 4. And that's the imaginary part, so you put 9 next to it. And then you add the real parts, the negative 2 plus negative 3, negative 5. And that's your answer. We usually put real part first and then imaginary part second, but they are the same thing. Square root of a negative number. This is where the number I comes from. Whenever you see the square root of a negative, you just have to poke out that imaginary number first and then square root whatever's left over. In this case, square root of 16 is 4, so it's just 4i. Real simple. 43, identify the axis of symmetry. Well, there's your parabola. Axis goes right through it, so that's x equals 5. That's A. And number 44, find the roots using the quadratic formula. Well, we know A is 1, B is negative 3.2, and C is negative 8, so just use that formula. It says negative of the B value, so negative 8. Says take your b and square it. So that's going to be negative 3.2. We got to square it. Minus 4 times a times c all over 2 times a. So there we go. Now the stuff underneath the radical, this is kind of messy always. Don't worry, take it in steps. Negative 3.2. So you get out your calculator and you go 3.2 and you square it. And yeah, it's a negative 3.2, but you're going to square a negative. It'll always become positive. So here's double negatives. That's 8 plus or minus square root of. And I put 3.2 in my calculator. I squared it and got 10.24. And then I'm going to do all this multiplication because I got to do that before I do any additions or subtractions. So that's 4 times 1 times 8. There's 2 negatives. That comes out to positive 32. 4 times 1 is 4, and 4 times 8 is 32. 2 times 1 on the bottom is just 2. So we're almost there. See, we're just cleaning up what's in the radical. Let's see here. 10.24 plus 32 is the square root of 42.24 over 2. Now, because we've got that decimal, we can go ahead and square root the 42.24, giving us 8 plus or minus the square root of 42.24. Well, actually, we're going to stop there because this is normally where we stop, everybody. You won't get one that has that weird decimal in there. At least you shouldn't. Now, if you do have one that has a weird decimal in there like that, yeah, just get out your calculator. Square root that 42.24. I'm going to double check the actual test to see if that's what they want you to do. I took the square root of 42.24. That gives me 6.5. And now I can write two answers. 8 plus 6.5, that's 14.5 over 2. 8 minus 6.5 is 1.5 over 2. And so those both simplify to 7.25. And 1.5 over 2 is 0.75. Those would be our two answers. And that is it.